Hello, I'm Takehiro Nakamura from NTT Docomo. Thank you for giving me an excellent opportunity to provide my presentation in this great event. I'm sorry I could not join the event in person, and I'd like to provide my video presentation instead. In this video presentation, I'd like to explain our views on 5G evolution and some our activities to promote millimeter wave deployment. At first, I'd like to explain 5G status quo of NTT Docomo. The number of 5G subscribers is increasing steadily. By this March, it reached about 22.5 million. And also, we expand collaboration with vertical partners to create new services and solutions under 5G Open Partner Program. Currently, we have over 5,000 partners. We are developing human resources, so-called 5G Master, to provide better solutions to our customers and for growth of our 5G business. To accelerate creation of 5G solutions, we are establishing 5G DX Square. We have now more than 50 sites. We've been creating many enterprise solutions with corporate customers. So far, we developed 5G enterprise solutions over 1,000 deals, such as remote diagnosis, remote education, smart city, remote control, and so on. And also, we deployed SA from the last year, and so many services are provided using AI and MEC inner network from the beginning of 5G. The solutions developed with partners are provided on this advanced 5G network utilizing benefit of 5G. This slide shows the spectrum assignment for 5G in Japan. 2 sub-6, 3.7 and 4.7 GHz bands and millimeter wave 28 GHz were allocated to 4 operators and deployed already. Bandwidth is 100 MHz for sub-6 and 400 MHz for millimeter wave. And please note that the dedicated spectrum were allocated for private 5G use, so-called local 5G, at 4.7 and 28 GHz bands. Similar to other countries and regions, 5G is deployed with sub-6 mainly in Japan so far. 28 GHz are deployed, but the area is so limited. Most of the traffic is transferred using sub-6. As you know, this is due to disadvantage of millimeter wave in terms of higher propagation loss and blockage loss. Millimeter wave is not so deployed and used well, as I mentioned in Japan and other countries. However, millimeter wave has excellent characteristics thanks to very wide spectrum band width, and we can achieve very high data rate, capacity, and low latency. We expect we need to use millimeter wave more in the future. This slide shows 4 reasons why we need to use millimeter wave. Mobile data traffic will increase continuously, and we need to deploy more spectrum resources. Left top figure is from GSMA report, and this report expects 5 GHz millimeter wave spectrum resources will be needed for eMBB, FWA, and enterprise solutions by 2030. Excellent high-quality 5G use cases such as 4K, 8K video, XR devices, robot, industrial automation will be provided in the future. This will need very high data rate and consume high capacity. Currently, joint communication and sensing is one very interesting technical topics, and higher frequency such as millimeter wave can improve accuracy of sensing. And also, more use of existing millimeter wave with advanced solutions can be an initial accomplishment that opens the way for millimeter wave and sub-terahertz deployment in 6G era. NTT Docomo has deployed 5G SA and dual connectivity with sub-6 plus millimeter wave from last year. Thanks to the dual connectivity, we can improve the performance, especially for uplink, with providing good 5G coverage. As I mentioned, millimeter wave is not so used well. This is due to three aspects: limited millimeter wave coverage, limited millimeter wave devices, and limited millimeter wave use cases. And these three aspects are not independent but closely related and making negative cycle. We need to change this negative cycle to positive cycle by millimeter wave coverage extension, spread of millimeter wave devices, and increasing millimeter wave use cases simultaneously. But it is not so easy to change the negative cycle to the positive cycle. We need cost reduction for devices and the installation. We should deploy higher TX power usage such as CPE to improve uplink performance. We need to promote emerging high-quality services such as XR, 8K video, and create new millimeter wave use cases. We operators deploy multiple frequencies considering various use cases. We should deploy millimeter wave taking into account millimeter wave characteristics, shorter cell radius, and high data rate and capacity as advantage. Millimeter wave should deploy at smaller and closed area where higher performance required, such as hotspot, stadium, event venue, indoor office, private network local 5G, and macro street, and so on. At early stage of millimeter wave deployment, area of millimeter wave is limited. However, area of millimeter wave should be extended according to spread of millimeter wave devices and increasing needs for higher performance. To promote millimeter wave deployment, we need new solutions to improve millimeter wave coverage efficiently, and they should be deployed with legacy deployment as new radio network topology. The new solutions should support desired features such as small size and lightweight, cost and energy efficient, easy and ready to use and inconspicuous. These solutions should be effective for sub-terahertz in 6E. We are investigating many technologies as the new solutions for the new radio network topology. As antenna technologies, we are testing on-glass antenna and the pinching antenna using dielectric waveguide. These solutions are inconspicuous and easy and ready to use. As radio X-Hole, radio fiber is a better solution for wider bandwidth signal of millimeter wave. OM-MIMO multiplexing can achieve super high speed data transmission for X-Hole. We have many repeater technologies. Millimeter wave repeater system, passive reflector, RIS, and the metasurface technologies are very interesting solutions which can extend millimeter wave coverage easily. We are studying these solutions and conducting field trials aggressively, aiming commercial deployment for millimeter wave promotion. As I mentioned earlier, millimeter wave features large bandwidth, narrow beam width, and high carrier frequency contributes to accurate sensing in terms of high range resolution, high angle resolution, and high velocity resolution respectively. Bottom figure shows a theoretical estimation on accuracy between millimeter wave and sub-6. Compared with sub-6, accuracy on range resolution, angle resolution, and velocity resolution can be greatly improved by 2 to 5 times. This slide shows our simulation results on millimeter wave coverage enhancement by RIS Network Controlled Repeater, RIS NCR. Simulation conditions are millimeter wave dense urban scenario with 3 blind spot areas per sector and 3 RIS NCRs deployed correspondingly. The simulation results showed that RIS NCR with 0.5 meter by 0.5 meter can eliminate the blind spot effect, and the RIS NCR with 1 meter by 1 meter can achieve 8 dB SINR improvement in average. This simulation results shows potential effectiveness of RIS-NCR for millimeter wave coverage enhancement. Please note that the millimeter wave promotion activities are led by Japanese regulator MIC and the 5G promotion organization 5GMF in Japan also. MIC established 5G business design working group to explore 5G business utilizing millimeter wave. In the working group discussion, members of the working group, including Docomo and the major operators and the vendors, expressed positive opinion for millimeter wave deployment. In 5G Mobile Communication Promotion Forum, 5GMF, millimeter wave promotion ad hoc was established in this January. Actually, I'm a chair of this ad hoc. The ad hoc published their white paper in this March and organizing event to promote millimeter wave. This slide shows the contents of the white paper of 5GMF millimeter wave promotion ad hoc. The white paper was published on 31st March this year. We made exhaustive discussion on millimeter wave, including challenges, technologies, solutions, and so on. And the results of our discussion was captured in the white paper. I'm sorry, we have no Chinese language version, but the Japanese and the English version was published, and you can download these from 5GMF webpage. I'm happy if you have interest in this white paper and give us your feedback or questions. That's my presentation. Thank you for your attention. I'm happy if you have more interest in millimeter wave deployment for 5G evolution in China and over the world so that we can develop millimeter wave ecosystem. This time, I'm sorry that I could not participate in this event in person. I hope I can have another opportunity to see you in 5G and 6G event in near future. Thank you. 谢谢。